Welcome to Linux Forensics, Chapter 9. This is your Professor Atif Fareed Mohammed. We will be looking into various types of digital forensics in Linux operating system and file system, what to look for in Linux system logs, forensically interesting Linux directories, important Linux shell commands, and how to undelete files from Linux. Let's look into that in a little bit more depth. History of Linux: 1969 Unix created, 72 Unix was released, GNU came out in 1983, 1987 Minix came out, 1991 Linux came out, and hundreds of Linux distros or distributions came out after. So Linux shells are Bourne shell, Bourne again shell, C shell, and Korn shell. Let's look into that at a little bit more depth. The Bourne shell, often referred to as SH, is one of the earliest and most fundamental command line interpreters in Unix-like operating systems, developed by Stephen Bourne at AT&T Bell Labs in the late 1970s. It introduced several key features that have become standard in shell scripting. These include control structures like if-then-else statements, loops, and functions, which allow users to write complex scripts for automating tasks. The Bourne shell is known for its simplicity and efficiency, making it a reliable choice for system administration and scripting. Despite its age, the Bourne shell remains relevant today, particularly in system initialization scripts and other low-level system tasks. Its syntax and features have influenced many subsequent shells, such as the Bourne again shell or Bash, which is widely used in modern Linux distributions. The Bourne shell legacy is evident in its continued use in Unix-based systems, where its straightforward and powerful scripting capabilities are shell valued for their reliability and performance. The C shell, commonly known as CSH, is another significant command line interpreter developed for Unix-like operating systems, created by Bill Joy at the University of California, Berkeley in the late 1970s. The C shell was designed to provide a more user-friendly and interactive experience compared to the Bourne shell. One of its standout features is its syntax, which is similar to the C programming language, making it more intuitive for users familiar with C. The C shell introduced several innovative features such as command history, aliasing, and job control, which greatly enhanced user productivity and interactivity. However, a C shell has faced criticism over the years for its limitations in scripting, particularly when compared to the Bourne shell and its successors like Bash. Issues with variable handling, error checking, and overall scripting robustness have led many users to prefer the shells for complex scripting tasks. Despite these drawbacks, the C shell remains appreciated for its interactive features and is still used by some users for its convenience in day-to-day command line operations. Its influence can be seen in other shells like the Tenex C shell or TCSH, which builds upon CSH with additional features and improvements. Now let's look into Korn shell. The Korn shell, often abbreviated at KSH, is a powerful and versatile command line interpreter developed by David Korn at Bell Labs in early 1980s. It was designed to combine the best features of both the Bourne shell, SH, and C shell, CSH, offering a robust and efficient environment for both interactive use and scripting. KSH introduced several advanced features such as enhanced job control, command line editing, and improved scripting capabilities, making it a favorite among system administrators and developers. Its syntax is largely compatible with Bourne shell, but it includes many enhancements that make it more user-friendly and powerful. One of the key strengths of the Corn shell is its performance and efficiency, which make it well suited for large scale scripting and system administration tasks. It supports features like coprocessing, which allows for advanced inter process communication, and has strong support for arrays and advanced string manipulation. Despite the rise of other shells like Bash, KSH remains a popular choice in many enterprise environments due to its reliability and comprehensive feature set. Its influence can be seen in various modern shells, and it continues to be maintained and updated, ensuring its relevance in today's computing landscape as well. mkdir, the mkdir command creates a new directory. Example, mkdir space directory name, mkdir space dash p, not the caps, will create parent directories as needed. Example would be mkdir space dash p space directory 1 slash directory 2 slash directory 3. And in this case, you can see directory 1 is pretty much looks like directory L. CD, the CD command is used to change directories. Example, CD directory name and CD space dot dot will go up one level in the directory tree, and this goes on. RM would be to remove the file or delete the file from your machine. So rmdir, the rmdir command is used to remove or delete entire directories. Example, rmdir space directory name. mv, the mv command is used to move file. Example, mv space myfile.txt space my folder. The ps command lists all currently running processes that the user has started. Any program or daemon is a process daemon. The ps dash a ps space dash a lists all processes for all users, not just the current user. ps space dash aux provides detail for each process, such as process id, percentage, or memory used. ps-tree command shows all processes, whether started by the current user or not, in a tree format, clearly showing which process started which other processes. This is definitely of interest forensically. Top, the top command lists all currently running processes, whether the user started them or not. It also lists more detail on the processes. Example is simple top command. fsck, the file system check, the fsck command can check to see whether the given partition is in good working condition. fsck space slash dev slash hdal, and we'll give it a try. fdisk is the fdisk command lists the various partitions, and the example is fdisk-1. The mount command mounts a partition, permitting you to work with an example. lsoff, the command lists open files. This is helpful in forensics to see not only what files are open, but also the processes which open them. lsattr. The command lists file attributes on Linux second extended file system. So GNOME looks like this on your screen. KDesktop environment or KDE Plasma looks like this. The other Linux graphical user interfaces or GUI are Common Desktop is CDE, originally developed in 1994 by Unix Systems based on HP's Visual User Environment or VUE. The Common Desktop Environment or CDE, developed by the consortium of companies including HP, IBM, and Sun Microsystems, was one of the earliest and most influential desktop environments for Unix and Unix-like operating systems. Introduced in early 1990s, CDE aimed to provide a standardized and user-friendly graphical interface that could run across different Unix platforms, addressing the need for consistency and ease of use in an era when the Unix systems were primarily command line based. CDE featured a familiar desktop metaphor with icons, windows, and a taskbar, making it more accessible to users who were not familiar with the intricacies of Unix command line operations. CDE included a suite of productivity applications such as File Manager, text editors, and terminal emulators, which were designed to integrate seamlessly with the desktop environment. Despite the initial, let me repeat myself. Despite its initial popularity and widespread adoption in enterprise environments, CDE eventually faced competition from more modern and flexible desktop environments like GNOME and KDE. Over time, many Unix vendors shifted their focus to these newer environments, which offered more advanced features and better support for contemporary hardware and software. However, CDE's legacy remains significant as it played a crucial role in bringing graphical user interfaces to Unix systems and paving the way for future desktop environments. Enlightenment is a highly customizable and visually appealing window manager and desktop environment for Unix-like operating systems. Known for its flexibility and aesthetic appeal, originally developed by Karsten Heitzler Rasterman in late 1990s, Enlightenment started as a window manager, but it has since evolved into a full-fledged desktop environment with wide range of features. One of its standout characteristics is its extensive configurability, permitting users to tailor almost any aspect of desktop to their preferences, from themes and animations to advanced window management behaviors. This level of customization has made Enlightenment a favorite among users who value both functionality and visual appeal. Enlightenment is designed to be lightweight and efficient, making it suitable for a variety of hardware from older systems to modern high-performance machines. It includes a suite of integrated applications and tools such as File Manager, Terminal Emulator, and System Monitoring Utilities, which are seamlessly integrated into a desktop environment. Despite its powerful features, Enlightenment has a learning curve due to its extensive configurability, which can be overwhelming for new users. However, its active community and comprehensive documentation provide ample support for those willing to explore its capabilities. Enlightenment continues to be developed and maintained with regular updates and improvements, ensuring its relevance in the ever-evolving landscape of desktop environments. Cinnamon is a modern and user-friendly desktop environment primarily developed for Linux distributions, with a particular focus on providing a traditional desktop experience. Initially created by the Linux Mint team, Cinnamon was designed to address the usability concerns that arose with the transition to the GNOME 3 desktop environment. Cinnamon offers a familiar and intuitive interface featuring a classic desktop layout with a panel, menu, and a system tray, making it easy for users to navigate and manage their applications and files. This traditional approach has made Cinnamon popular among users who prefer a straightforward and efficient desktop experience. One of the key strengths of Cinnamon is its balance between simplicity and customization. While it provides a polished and cohesive out of the box experience, it also offers a range of customization options, permitting users to tailor the desktop to their needs without overwhelming them with complexity. Cinnamon includes a set of integrated tools and utilities such as the Nemo File Manager and various system settings panel, which enhance productivity and ease of use. The desktop environment is known for its stability and performance, making it a reliable choice for both casual users and professionals. Cinnamon continues to be actively developed and maintained with regular updates and improvements, ensuring that it remains a competitive and relevant option in the Linux desktop ecosystem. LXDE, which stands for Lightweight X11 Desktop Environment, is a fast, energy efficient, and user friendly desktop environment designed for Unix and Linux based operating systems. Developed with a focus on performance and resource efficiencies, LXDE is particularly well suited for older hardware, low powered devices, and systems with limited resources. Its lightweight nature ensures that it runs smoothly even on machines with minimal RAM and processing power, making it an ideal choice for reviving older computers on or running on lightweight distributions like Lubuntu. One of the key advantages of LXDE is its simplicity and ease of use. The desktop environment provides a clean and intuitive interface with a traditional layout that includes a panel, menu, and the system tray, making it accessible for users of all skill levels. Despite its lightweight design, LXDE offers a comprehensive set of applications and tools such as PCMAN FM File Manager, LX Terminal, and various system utilities which are optimized for performance and integration. LXDE's module design allows users to easily add or remove components based on their needs, further enhancing its flexibility. While LXDE may not offer the same level of advanced features and eye candy as some other desktop environments, its focus on speed, stability, and usability makes it a popular choice for users seeking efficient and straightforward desktop experience. So the typical default active services look like this: halt, single user mode, not used, user definable, full multi-user mode without GUI, not used, user definable, full multi-user mode with GUI, and reboot. Logical volume management. Now let's look into this with an example. Logical volume management (LVM) is a powerful and flexible system for managing disk storage in Unix-like operating systems, including Linux. It provides a higher level of abstraction compared to traditional partitioning, permitting for more dynamic and efficient use of storage space. LVM introduces several key concepts such as physical volumes, volume groups, and logical volumes, which work together to create versatile storage management solution. Physical volumes are the underlying disk partitions or entire disks that are used as building blocks. These PVs, or the physical volumes, are combined into volume groups, which act as pool of storage space within these VGs or the volume groups. Logical volumes are created and managed, providing the actual storage containers that the operating system and application use. One of the major advantages of LVM is its ability to resize logical volume on the fly without the need to unmount or disrupt the file system. This dynamic resizing capability is invaluable for system administrators who need to adjust storage allocations in response to changing the demands. LVM also supports features like snapshotting, which allows for creation of point in time copied of logical volumes, useful for backups and testing. Additionally, LVM can strip data across multiple disks for improved performance and can mirror data for enhanced redundancy and fault tolerance. This combination of flexibility, performance, and reliability makes LVM a predefined choice for managing storage in both desktop and enterprise environments. Linux distributions, there are Ubuntu, Red Hat, Enterprise Linux, OpenSUSE, Debian, Mint, Fedora, CentOS. The Linux logs look like this: failed users' logins, messages from operating system's kernel, items that have been printed, email activity, MySQL database, server activity, Apache web server activity, Lite, TPD, web server activity, application crashes, and suspicious traffic. Linux directories. Let's look into that with an example. In Linux, directories plays a crucial role in organizing and managing files within the file system. The directory structure in Linux is hierarchical, as mentioned earlier. At the top, serving as the foundation from which all other directories and files branch out, is actually slash. This hierarchical structure allows for a logical and organized way to store and access data, making it easier for users and administrators to navigate and manage the system. The key directories are important to the functioning of every operating system. Directories are also important places to seek out evidence in an investigation. The root directory, home directory for the root, contains the data for the administrator. Linux root user is equivalent to Windows administrator. The bin directory has all and everything. So that's something that I suggest you to look into. The bin or sbin. These directories hold essential system binaries. /bin contains binaries that are necessary for all users, basic commands like ls and cp, while /sbin contains system administration binaries that are all typically used for the root user. The etc directory contains configuration files such as for web servers, bootloaders, security software, and many other applications, an attractive target for hackers. The sets boot up process and operation. Example, init level for the system startup has label, run level, action, :A, process, boot, boot weight, init default, and sysinit. So I just thought to share this with you because this is important. It remains in the etc init tab file. The dev directory contains device files, interfaces to devices. All devices should have a device file in dev. Device names conventions are HD is hard drive, FD is floppy drive, CD is CD drive. The MNT directory has many devices are mounted in /MNT. Drives must be mounted prior to use. Checking this directory lets you know what is currently mounted in the system. The /boot directory contains files critical for booting. Bootloader, LILO, or grub looks in this directory. Kernel images commonly located in a boot. Then we have the user directory contains subdirectories for the individual users. The TMP directory contains files that are needed temporarily, can find data regarding what has been happening most recently on the system. Files stored here get removed immediately on system reboot, must be searched live. var/temp made available for programs that require temporary files. Files remain for 30 days by default. var backups contains backups for various system files such as etc shadow and etc init.conf for configuration. Files usually named with a .bak extension or number such as .0, .1, etc. var spool contains the print queue. The proc directory looks like this. The run directory looks like this. Shell commands. Linux has hundreds of shell commands. Some can be very useful in forensic investigation, like dmest command, fsck, grep, history, mount, ps, ps3, and the list can go on. The dmest command looks like this. ps3 command looks like this. File command looks like this. Finding executables look like this. Checking scheduled tasks. Finding oddities look like this. Undeleting Linux files manually. Move system to the single user mode. Use grep or similar command. Grep space -b search -text and then /dev/partition greater than file.txt. Use command line editor to view the file. Kali Linux Forensics has a number of forensic tools. can use as quality control tool to complement OS forensics FTK and NCase or NCase. Includes Autopsy, a web-based graphical user interface for the command line tool like SlothKit. Autopsy command window looks like this. Autopsy web interface looks like this. Autopsy new case looks like this. New host looks like this. Verify the hash looks like this. Autopsy image is added like that. Forensic tools for Linux: create a forensic image of the machine, verify the image using an appropriate hashing algorithm, mount the image as if it were a vital or virtual machine using a tool like Forensic Explorer, creates a read-only forensic image, can navigate to needed folders and logs, can execute shell commands and gather information on the target system. In this lecture, we have discussed Linux operating system and file systems, what to look for in Linux system logs, forensically interesting Linux directories, important Linux shell commands, how to undelete files from Linux. See you soon in the next lecture.